Here we go. Just turn this 16 kg flywheel handle, and you can drive this machine from. Of course, as you can see, this century-old antique still works, but its condition isn't great. So this man starting the disassembly restoration master, Mr. Patton and Mr. P, will give it a perfect restoration. Structurally speaking, this flywheel press, compared to the ones we've seen, those manual presses, the biggest difference is the flywheel. Compared to traditional round ones, this design is simpler. By adding to both ends of the handle 2 8 kg flywheel weights. This setup serves three main purposes: increase inertia, save effort, ensure more power at impact. So, when you turn the handle, the flywheel's mass creates inertia, storing the energy applied by hand. Then, this energy passes through the central threaded spindle, instantly becoming huge downward pressure. Back then, before electric motors, craftsmen used this mechanical structure to amplify human strength, enough to change the shape of metal for punching, stamping, riveting, or even small-scale forging. If you want more pressure, what do? The answer is simple and direct. Just scale up the machine like this. Now Pargo has finished the entire disassembly. Next, he'll use sandblasting on the painted parts to remove paint and rust. The abrasive used this time is black corundum. After sandblasting through this bare steel color, we can see many parts have flaws of all sizes. Here is even a very deep pit here, and a broken screw hidden here. So now, Pargo needs to first extract this screw. The process is simple. Grind it flat, use a center punch, drill a hole, and use an extractor to remove it. After removing the screw, he'll use a grinder on those cracks to create a better welding surface. Then use welding to fill these defects. Before welding, the welding area must be preheated. Preheating reduces the temperature gradient to avoid internal stress from huge temperature differences and the risk of cold cracks. As for grinding the surface, besides expanding the area for better bonding, it removes oxidation and contaminants. After welding, EXC/ESS filler can be ground away. Then, using various tools, these parts are ground, smoothed, and chamfered. Also, the threaded parts need to be repaired with a tap. After shaping, sandblast it again to remove welding oxidation marks. Minus 108,088,800. Once sandblasted, start powder coating. First, apply a gray powder primer. Once evenly coated, bake at 180 degrees Celsius for 10 minutes. to cure the powder. Unfortunately, the oven is closed, so we can't see the transformation. Now, use 180 grit sandpaper to sand the primer. Then use masking tape to cover contact surfaces. Next, use cold weld to fill surface pits. Cold weld is stronger than regular putty because it's made of structural glue and metal filler. Putty, however, is mostly polyester resin and talcum powder fillers. Once smooth 1080, he sprays these parts with RAL 7024 graphite grey top coat. After painting, to assemble the parts, treat these bolts and nuts. For these fasteners, we know the drill: sand, polish, and nickel plate. Due to their shape, the sanding step can be done on a lathe. As for this, for a better polish, he uses 3 different polishing waxes to finish the job. Now, the finished bolts and nuts ... and place it into the green nickel solution for the plating process. To protect the surface and distribute pressure, increase stability, and prevent loosening, Poco also made 4 of these washers. With the fasteners ready, the base and body are assembled. Next is the central axis. The first part to handle is the threaded axis sleeve. Poco uses an ultrasonic cleaner to give this 2-part sleeve an initial cleaning. Once cleaned, these 2 halves can be joined. Then, using a lathe, they are sanded and shaped. After finishing the exterior, the threaded holes and inner walls are processed. Finally, after polishing, nickel and copper plating begin. Hearing this, does it seem a bit odd? Usually, you plate copper then nickel. Copper is more ductile, filling tiny surface defects and improving adhesion. Nickel is harder and offers better protection. The reason for reversing this is simple. It's to restore the original finish. This massive nut got the same treatment, shaping, then nickel and copper plating. Also, one detail: for the copper plating, Poco uses brush plating. This way, the moving parts, the axis and sleeve walls, keep their wear-resistant, high-performance nickel layer. To assemble the sleeve halves, Pagos make a new 1-pun, a new, healthy fixing bolt. With the new bolt, we can add the sleeve, apply plenty of grease, and get the whole spindle assembled in place. Next is the return spring. As the name implies, its job is to use spring tension to lift the press spindle and prevent jamming. For the upper fastener, we'll use the same treatment as the sleeve. These two deformed springs are much harder to fix. First, Pargo uses heat shaping to gradually correct the deformed parts. Now, I am sure many of you know that after heating, the spring has been annealed and softened, losing its elasticity. To restore elasticity after straightening, the spring must be heated to the austenite zone between 750 to 850 degrees Celsius, then oil quenched to create high hardness. But quench springs are brittle, so they need low temp tempering to transform the structure and balance strength and toughness. Once tempered, the spring regains its elasticity. After polishing and cleaning, these two springs are done. As for the cross-shaped part, it's quite simple. Just reshape and nickel plate it. Now Pargo can put the restored return spring back into place. Next is the flywheel handle. With these solid saucer-shaped ends, the process is simple and standard. Sand them smooth, mirror polish, then nickel and copper plate. As for this handle, the treatment is exactly the same, but it has a major problem. It's crooked. So, I need to add a shape correction step. Once this heavy flywheel handle is on, all original parts are finished. But it's still missing a work platform, so I use CNC technology to turn this 8 miles Limet 7075 aluminum plate into the platform we need. For a more refined finish, this platform will also be processed on a grinder. Besides the installed platform, I also specially made this press head. Finally, I'll install a Pager logo nameplate. This 1920s German manual flywheel press is now officially restored. That's all for this VIKY. Thanks for watching. Time flies when you are having fun. It's time to say goodbye. Thanks again for visiting Max's Restoration. Bye bye.